session. I am going to talk about hygienic design for food robots, and I'm going to focus on what matters most when it comes to those. A few words on myself. My name is Mathias Konne. I work for Staubli Robotics. I am the head of the food business for Staubli Robotics. We are a specialized company in different industries like semicon, pharma, surgeries, but also food. So about 2 years ago, I took the position of the lead on this team, and we've been building a specific teams of expert in North America and globally to support this industry because it has some very specific needs. So when it comes to robots for the food industry, and by that I mean robots that are focusing on primary applications in the washdown environment. We really focus on two things that I think are equally important. One of them is the washdown resistance, and the other one is the hygienic design. So that's why I put on this slide here. It really accounts for 50% each, and you really want to pay attention to those two aspects when it comes to robotics for food applications. How does that translate in the product? So basically, what I look for when I look for a hygienic robot for a washdown application, a food contact application, if I look at the hygienic design, first of all, I look at the overall design of the robot, right? Do you see the motors? Are there any exposed joints, stuff like that? So I'm really looking for a fully enclosed, clean design. The other thing I really pay attention to is the surface. Is it smooth? Do they use materials that are smooth? Do they do specific surface treatments? Because you want that drainage. So you want that smooth, non-harboring surface for bacteria to keep everybody safe and everything clean and dry. Other thing I look for, kind of like the enclosed structure, is external cables. Is the harness inside the robot? Is it messy outside the robot? Is it dangling off the robot? Is it going to be hard to clean? So I look for that as well. Another thing I look for, today's technology, with some robots like Staubli, for example, you're able to get away from the covers. Those big covers you put on the robots, they're not really hygienic. They have a lot of condensation issues inside. Usually it's pretty nasty when you open them. It's hard to clean, it's expensive. So I kind of look for those new technologies that are not using covers. Another thing I look for is obviously the H1 food grade oil in those robots to guarantee the safety of everyone should an issue arise. So that's very important. And what I look for in that is also the performance. So I'm going to look for, is it impacting the robot's life? Is it impacting the performance? Are we losing performance? Because a robot is a performing machine, right? So you don't want that to impact the robot. And again, with today's technology, you can do that. So I definitely look for that all in that performance. And lastly, I look for no retention zones. So it's kind of going along with the hygienic design, but you don't want any pockets, any flat surfaces that could create retention after the washdown of the liquids being used. And that could become a problem for bacteria contamination and stuff like that too. So these are kind of the things I look at on the hygienic design side. Now, when I look on the washdown side, the resistance of the washdown, first indicator is the pH resistance. So I look at that because we're using harsh chemicals in food plants. You want to make sure that the machine can sustain that. The other thing is the temperature resistance. They're going to be exposed to cold, hot, steam. So you kind of want to also have an idea of what's the resistance to different temperatures. Another big thing, obviously, a lot of people talk about IP ratings. I can dive into that in the next slide a little bit, but pressure resistance. When we talk about those mechanical impacts, that's very important. The pressure of those jets that are going to be used against the robot, you want to be able to have an understanding of that and what the robot can take or cannot take. Finally, 3 more points, food compliant materials. So here I'm looking for what materials are being used. Are they using stainless steel? Are there any kind of materials that are being used that could be problematic for food or dangerous or suspected corrosion? So you kind of want to look for those as well. Easy maintenance, that's a big one I want to bring up. It's not really directly related to washdown resistance, but food plants damage things, and you want to make sure that robots can be easy to maintain. You can get proper training, and that can, you can minimize the downtime, and you can plan the downtime of those machines. So that's another big thing I look at, and it's kind of related to washdown because of the impact of the washdown on the machines. And a last thing that for me is a big indicator is a history of resilience. And what I mean by that is, have you seen those robots, that very specific machine being used somewhere else? How is it doing there? Kind of look for that track, track of the record of success that the machine has. That's a big indicator also because now they're more and more present in food plants. So try to get some history on those machines. And my last slide is just to cover IP ratings because it's a hot topic. And a lot of my conversations in the food automation world revolves around IP rating when it comes to food. So I wanted to just go over very quickly what it covers and what it doesn't cover. Because in my conversations, a lot of times people confuse IP for washdown hygienic rating. And that's not the case. IP only focuses on the resistance to pressure, jets, submersion, dust, things of that nature. So you have different numbers. There's a code. It's an official rating. So everything has a structure. And you can kind of see here the most common that we see in the field, 65, 67, 69K. Sometimes you see IP 54. So you want to look for those and kind of understand what they mean. And it's not the end of all, right? So what it don't cover is the chemical resistance. Again, I talked about that. It's very difficult for a robot to manage the pH of some of those chemicals being used, the acidity. So you want to look for that. That's not covered by IP. It also doesn't cover hygienic design and cleanability at all. So it's not an indicator of that. And finally, it doesn't cover the compliance of the materials being used. So going back to the previous slide, kind of put it in perspective here, because a lot of times people tend to confuse IP rating with hygienic washdown. It's not exactly the same thing. So I kind of want to touch on that today. Thank you for the time. I hope you enjoyed the quick presentation and reach out to me for more information.